Today's lesson is about converse, inverse, and contrapositive. Let's talk about the converse first. For example, for the statement if P then Q, the converse will be if Q then P. In other words, we can write down this way. The converse of the statement P implies Q is the statement Q implies P. For example, if I live in Houston, then I live in Texas. The converse will be if I live in Texas, then I live in Houston. Just need to switch if then. That's a converse. The converse has a truth table. We just need to check here, implication rule. So for implication means all true except true false. So we use Q implies P. Need to find the true false. This is a false. Rest of them will be true. Now let's talk about inverse. For if P then Q, inverse will be if not P then not Q. So I can write down if not P then not Q. So we can use a symbol. The inverse statement of P implies Q is the statement not P implies not Q. For example, if I live in Houston, then I live in Texas. The inverse will be if I don't live in Houston, then I do not live in Texas. Let's talk about truth table for inverse. We have PQ, not P, not Q. Then from not P implies not Q. Implication here. For implication, all true except true false. Not P implies not Q. Only true false will be false. Rest of them will be true. Now let's talk about the contrapositive. The contrapositive of if P then Q is if not Q then not P. In other words, the contrapositive of a statement P implies Q is the statement not Q implies not P. For example, if I live in Houston, then I live in Texas. The contrapositive will be if I don't live in Texas, then I don't live in Houston. Let's set up a truth table for contrapositive. So for implication, all true except true false. Therefore, not Q implies not P. True, false, this is a false. Rest will be true. Here's the relationship between implication, converse, inverse, and contrapositive. Implication and contrapositive, they are logically equivalent. For converse and inverse, they are also logically equivalent. Guided practice 1. Two propositions P and Q are defined as follows. P, the number ends in 0. Q, the number is divisible by 5. Write in words. P implies Q. So we use if then statement. If the number ends in 0, then the number is divisible by 5. For second one from A, the converse of P implies Q. That means Q implies P. Therefore, if the number is divisible by 5, then the number ends in 0. Let's go to B. Write in symbolic form. The inverse of P implies Q. Inverse means not P implies not Q. The contrapositive of P implies Q. Not Q implies not P. Guided practice 2. Let P and Q be statements. P. You watch the music TV channel. You like music. A. Consider the following logic statement. If you watch the music TV channel, then you like music. Write down in words the inverse of the statement. Inverse means not P implies not Q. In other words, if not P, then not Q. So we can write down like this. If you don't watch the music TV channel, then you don't like music. Now let's go to second one from A. Write down in words the converse of the statement. Converse will be if P then Q. Converse will be if Q than P. Therefore, for Converse, if you like music, then you watch the music TV channel. Let's go to B. Construct truth tables for the following statement. So we use this truth table to set up the first two. PQ, we set up true, 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 false. False, true, false, false. P implies Q is given here. So we'll get true, false, true, true, which means all true except true, false. Not P means opposite of P. So we have false, false, true, true. Not Q means opposite of Q. So false, true, false, true. Not P implies not Q. Check these two columns. All true except true, false. So true, false. This will be false. Rest of them will be true, true, true. So we finished setting up the first two now. Now let's set up 3 and 4. So we have not Q, then P or not Q, not P, not P and Q. Still true, 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 false. False, true, false, false. Not Q will be opposite of Q. So we have false, true, false, true. P or not Q. Or means to be true, at least one is true. In other words, when both false will be false, otherwise will be true. So here is a false. This true, true, true. Not P means opposite of P. So we have false, false, true, true. Now let's check not P and not Q. To be true, both must be true. So this is true. The rest of them will be false. Let's go to C. Which of the statements in part B are logically equivalent? Check this, here, and here. Let's label. This is 1. Here's 2. This will be 3 and 4. Check which two are exactly same. And you could say these two exactly same. Therefore, 2 and 3 are logically equivalent.